But we're taking this region and we're rotating it around a vertical line this time. All right, so we're rotating this around the line x equals 10. Which is going to change the way we set things up, because the directions still told us to do this finding the volume using shells. So remember, shells have to be parallel. So the axis of revolution and the rectangle have to be parallel to each other. So we're going to use a vertical rectangle this time, which means a dx cut. Everything's going to be in terms of x. All right, so we're rotating this rectangle around this line. I'm going to draw this kind of scaled down here. We've got a vertical rectangle spinning around this vertical axis, so we've got another rectangle here. If we spin that around, we get a shell. All right, our average radius goes from the axis to the rectangle. And then our height is just the height of the rectangle. We know the thickness in this one is going to be dx, so everything is going to be in terms of x. So our average radius, we're taking the x value of this axis minus the x value of the curve. So the axis is at 10. The curve, we're just using x. It's just 10 minus x. That's going to change along this curve. We're just using x since it's a dx cut. The height, well, top minus bottom. The top part is that curve minus the bottom is just 0. So we don't even really need to write the minus 0 part. It's just basically going to be the height of this curve. But since we're doing this in terms of x, we can't just use like the y value, right? Basically the height is the y value of the curve. So we have to put it in terms of x. We know the curve is x equals y cubed. So what's y equal to? Cube root of x. So we've got all the parts we need to write our definite integral. We have 2 pi times definite integral from a to b, which we'll fill in a second. 10 minus x times the cube root of x dx. So our lowest x value, smallest x value is over here. That's at 0. Biggest x value is over here. That's 8 in that line, right? The whole line, x equals 8. That's as far right as we get.